coming in, but I'm going to go ahead and start. In case any of you aren't aware, we will be recording this, and we will also be putting that up on the YouTube channel for the competition later on, which you will have a link for. So I'm going to go ahead and get started. My name's Tim Arnett. I'm one of the organizers for the Explainable Fuzzy Challenge for 2022. This is a year-long competition where we will be doing several things throughout the fall, culminating in a competition next spring towards the end of the spring semester. This challenge is a collaboration between the University of Cincinnati. So we have a couple organizers from the University of Cincinnati and a couple from Thales, which is the company that I work for. And then we also have had some contributions from NAFIPS, which is the North American Fuzzy Information Processing Society, which I see we have a few people from on the call as well. Next slide. So some general info. We have a website. This is the link for the website. We have quite a bit of information on there, including all of the information from last year's competition. We will be updating this periodically. We have a registration link, which we did have a deadline of yesterday for registration. We are going to extend that, however, to the end of the week because I think we had several people who either didn't get to register in time, or we might have others that just weren't aware of it yet. So we'll be extending that. The link is right there on the main page of that website. We also have a Slack, which is at this. You can access it by going to this link, ucfuzzycompetition.slack.com. It'll then prompt you for your login information, which you can then enter in, and you'll be part of our Slack channel. We use this fairly often for communicating with the teams. In fact, it's one of the primary methods that we use for like day-to-day communication. For broader announcements, we will still email the email list for the entire competition, but the Slack is very useful also because you can communicate with other teams. You can bounce ideas off of teams if you want. We've also had some teams consider grouping up together. And related to that, we've said that we are going to limit it to 6 students maximum per team, and any major is welcome, by the way. This isn't limited to people who are experts in fuzzy or EE, aerospace, anything. Any major is welcome. I will say that although single student teams are allowed, if anybody is by themselves and they would like to be potentially paired up with someone else or join another team, we will do that through Slack. So I highly encourage everybody to join the Slack, if for no other reason than to get more information from us throughout the year. One thing to know is that all of our coding and environment and deliverables, etc., will be in Python. So it's not a strict prerequisite that you are an expert in Python, but you may want to at least have the basics down before you try to do a lot of the deliverables and milestones in the competition, which we will have a number of resources that we will point the teams towards also for getting up to speed, not just in Python, but things like repository management and things like that as well. Next slide. So this is a general outline of the rest of the talk today. So we're going to go over the introduction. Then I'm going to talk about the organizers. We're going to have a brief thing on explainable AI. Dr. Kelly Cohen can't be with us today, but we do have Dr. Nick Ernest from Thales on the line to give a short perspective on explainable AI. We're also going to get into the details of the challenge itself, which deals with a game called Asteroid Smasher, which is in Python. We'll then go over the timeline. We do have some helpful links and resources at the end, and then we can get into Q&A. Next slide. So the introduction, I've already mentioned some of this, but the Explainable Fuzzy Challenge for this year is a competition using fuzzy logic and AI learning methods to solve, some problem. We have a very specific problem that will change year to year. This year, the problem is creating an AI control system to control agents in the Python arcade game Asteroid Smasher. We'll give a lot more details about that, but it's basically a video game where you have a small agent that has to avoid asteroids and also destroy them. The challenge will involve multiple milestones based on solving subproblems with fuzzy logic and optimization algorithms. This year, those milestones are optional, but they are highly encouraged to ensure that you're on the right track. And we'll have dates as sort of guidelines for when you should be reaching those milestones. And of course, this culminates in a virtual competition where we will take each team's AI solution and we will evaluate it in a number of Asteroid Smasher scenarios, many of which you will not have seen before. Or I should say your AI agents will have not seen before. There will be monetary prizes for the top teams. We'll have a podium for second, third, and then we'll also have awards for most innovative solution, most explainable solution. And last year we had most efficient solution too, and it's likely that we will have an award for that as well again this year. Next slide. So these are the organizers. First, on the left, we have Javier Viana. He couldn't join the call today, but he is a PhD candidate at the University of Cincinnati, and he is the primary point of contact for the competition. So if you have general questions about the competition, registration, things like that, you can go ahead and ping Javier, and his email address is on here. You also have access to all of that information in the Slack and the website. Next, we have Lynn Pickering, who's also a PhD, I believe, candidate now at the University of Cincinnati. She will also be the point of contact for code and fuzzy toolbox questions, and her email as well. Brandon Kunkel, who is my coworker at Talus, he is a senior AI engineer in our office. He will be point of contact for very specific code and repo related questions, but also Lynn and Javier can handle that as well. In fact, I would say primarily go to Javier and Lynn first, and then myself and Brandon if need be. And then finally, I'm Dr. Tim Arnett. I'm a verification lead for AI systems at Talus. You can contact me though if you have questions about the milestones and seminar information. And our email addresses are here at the bottom as well. Next slide. We also have Dr. Kelly Cohen, who's a professor at the University of Cincinnati in the Department of Aerospace Engineering and Engineering Mechanics. He is, the person for fuzzy at the University of Cincinnati, and has been instrumental in helping us get this competition off the ground. We also have Dr. Nick Ernest, who's the chief architect of our Talus office here in Cincinnati, who is also very familiar with fuzzy. And I believe, Nick, if you're on the line, he would like to say a few words about the competition. Nick?
Yeah, certainly. No problem, Tim. So first of all, thank you all for your interest. I'll also want to thank NAFIPS and UC for their partnership in this effort. Last year, this is our second year in this competition, of course. Last year was a great success, and I expect that everything will just be all that much better this year. So real quick, my name is Nick Ernest. I'm the chief architect in particular for Talus Avionics, and I run the research lab out of Cincinnati, Ohio, that is primarily aimed towards this sort of fuzzy logic. So when it comes to fuzzy, if any of you are familiar, it has a lot of pluses, but one of its main ones that obviously we're focusing on here is explainability. Large push in AI across a wide array of domains right now. Capabilities of AI are ever increasing, but there's a huge need for explainability, especially if we're talking about mission and safety critical applications or those that involve human machine teaming. So this may just be a fun little video game that you'll be building for during this competition. The value behind an explainable AI to control an agent through this sort of problem is very high. So I'll kind of leave it at that. Thank you again for your interest, and I greatly look forward to seeing what comes out of this competition.
Thanks, Nick. Yeah, me too. We had some really interesting solutions last year, some very high performing, and I'm excited to see what the teams come up with this year. Next slide, please. So Nick already talked a bit about explainable AI, but to go a bit deeper, what is explainability? And we want to be able to explain the decisions made by AI systems. Why did the system make this decision? When can you trust the decision? And more generally, the AI. And can I make sure that the answer given to me based on something will be something? If you want to verify that the AI solution has given you what you want. This is becoming a bigger and bigger focus every year. There's a large focus specifically from organizations like DARPA, along with, in the commercial sector, Google and Amazon. There's a big focus on this. They don't just want high performing solutions, but they want to be able to explain why it arrived at a particular decision. And again, many popular AI methods don't inherently have this property. There have been advances to do this after the fact, but can still have issues with interpretability as well. Next slide, please. Okay. And fuzzy logic is a good blend of having the benefits of explainability, but also having good approximation capabilities. It also has the universal approximation capability, similar to things like neural nets, but it can also be represented using linguistic if-then rules. It's been widely used in industry and academia for more than 40 years. Popularity has faded in the mainstream AI approaches, I would say, due to a couple issues, one of which is dimensionality. This is and has been mitigated somewhat with the introduction of what are called fuzzy trees back in 2015. And these systems have had successful pairings with a number of optimization algorithms for all different types of learning: supervised, semi-supervised, unsupervised, and gradient-free learning. Some of these can also include backpropagation, genetic algorithms, reinforcement learning, many others. So it's a fairly powerful methodology to use if explainability and approximation capability are both of interest. Next slide, please. So to get into the timeline, so this is for fall semester. So today, September 7th, we have the kickoff. Next Monday, the 13th, we will have an introduction to the Asteroid Smasher game itself. This is a Python arcade game, which we'll give more details on, but we'll go over it more in depth and also the modifications that are made to the game in order for the competition. Then a week after that, on Monday, we have a seminar on fuzzy inference systems. So we will be going over both fuzzy logic, fuzzy inference systems, and then also a brief introduction to fuzzy trees. After that, on September 27th, we have a guest speaker, Dr. Jerry Mendel from the University of Southern California, and he's going to give a talk on explainability in fuzzy systems. He has a wonderful paper on explainability in fuzzy systems through IEEE, describing that basically explainability or the linguistic representation of certain terms and how those are represented using fuzzy sets. So that'll be very useful for the explainability aspect of your systems. Next slide, please. After that, on October 4th, we will have our first seminar on optimization. This one will be on genetic algorithms and other gradient-free optimization algorithms. After that, in October, we don't have a set date for this, but we will have a follow-up seminar on gradient descent for fuzzy systems given by Dr. Barnabas Bede from DigiPen. After this, we have a date set aside currently for a sort of an open help session on October 18th. We will have a number of these throughout the year. So this one is a dedicated date that we have set up, but we will have floating dates that we'll have more help sessions as needed. Then on November 8th, we will have the competition introduction. So you'll already have been exposed to the game itself and how to interact with it and stuff like that. But then on November 8th, we'll get into more of the details about the competition. So it'll be the format of the competition day. We'll talk about scoring and how all the solutions will be scored, etc. Next slide, please. Then in spring, so we'll have a spring kickoff and help session once the winter break is over. So this is set for January 18th next year. We will have a number of help sessions. They're not on here explicitly, but there will be a number of sessions in between this kickoff and qualifying. Qualifying, by the way, is on March 7th. And I'm going to say qualify in quotes because it's really just to ensure that we have seamless integration between code that the student teams are providing. So they must provide us an initial version of their solution just to make sure that it integrates and runs with the environment code that we have and that it functions as expected and can quote unquote solve some sort of extremely simple scenario. Basically, one vehicle, one asteroid, can it just move or shoot the asteroid at all? So it's basically just a final check on progress and ensures that we can run everything smoothly for the competition. The performance outside of that won't be a factor. Then on April 4th, the final version of your AI agents and code will be due to us. And so you must have your own repository for your code, and you must share that with the organizers so they can access your code and load it into the environment for the competition. And we'll go over some basics on repository management, how to do some things like that. But I would recommend also going through those resources that we provide for that as well. Then on April 9th will be competition day. So we will, depending on the final number of teams, we will have a set aside amount of time for each of them to discuss their approach and their solution. So a short presentation. And then we will take each team's solution and we'll evaluate them over a number of scenarios in real time. So we'll actually get to watch their AI solutions solving some of these problems. And they won't be problems that they have seen before in training. This event will be live streamed and we'll have the organizers there commentating live, giving some feedback. We may also be talking to team leads during the competition, asking them certain questions about their solution, what they expect to see, that sort of thing. Last year's, it was a lot of fun. We expect this year's to be even more fun. And, we'll be sharing this with quite a few people. And by the way, all of our seminars and the competition, they will be recorded, and we do have a YouTube channel where we will be uploading all of this. In fact, you can go to our YouTube channel, which I don't know if we have the link in the. Lynn, do you mind putting the link in the chat for everybody for the YouTube channel?
Yeah, I'll see if I can get that.
Okay, thank you. Yeah, so you can see the live stream from last year, and also a highlight video that Brandon Kunkel, one of the other organizers, made for the competition. He used clips from the live stream, and yeah, it's a lot of fun. Next slide, please. I mentioned the milestones. This year they will be optional, and we say assigned, but really we'll just be detailing these milestones, and we'll give those at the end of each seminar. So there will be one after the fuzzy seminar, one after the optimization seminar, etc. And they're recommended just to ensure that you're on pace. So the first milestone we'll have is basically a hello world in Asteroid Smasher. It'll basically just be making sure that you can interact with the code, make modifications, and still have it run, that sort of thing. Second milestone we'll have is using a fuzzy inference system for controlling aspects within Asteroid Smasher. And then finally, we'll have a milestone where you combine all of these things along with some sort of optimization algorithm or learning algorithm, whether that's gradient free or reinforcement learning, something like that, just to ensure that you can get an AI agent training within the environment. Next slide. Okay, and now I'm going to hand it over to Lynn Pickering, who's one of our other organizers, and she's going to talk a bit more about the challenge.
Hello, everyone. So like Tim said, I'm going to talk some more about the challenge. So you guys are going to create an AI player to play the Python arcade game Asteroid Smasher. The organizers, we manage the Asteroid game repo, and we'll send links out to everyone on that when we're ready. And you will also, as Tim mentioned, you will need to create your own AI solution repository. And like we said, you'll be getting skills on, you'll be learning some more about how to do repository management and things like that to make that go smoothly. And overall, like it kind of says in the title, we're going after explainable AI here. So the AI you create needs to be explainable, and it must utilize fuzzy logic. There are other algorithms allowed, for pre-processing, and always make sure to ask us based on the situation. If you have any questions, definitely ask us. But that explainability will factor into the final scoring criteria, along with creating a method for visualization of the explainability of your system. So it really is not just going to be the performance by itself. So I've got the link here. You can go check out, that's the original Python arcade game, but we've definitely made some changes. So once you guys have access to the repository and everything, that will be where to check out the game. And it is 3 degrees of freedom simulation. It wraps at these edges here. So these asteroids can come off and enter on the other side, just like the ships. The vehicle can rotate, move forwards and backwards, and fire these bullets here. Asteroids hit with the projectiles will break into smaller pieces until it's the smallest asteroid, and then it just disappears. And any piece contacting the vehicle destroys it. And this year, we're really excited about is that we have modified this to be multi-agent. So you guys are actually, your control system is going to need to be able to handle one agent situations and also 2 agent situations. So that's kind of a big change we have from last year. And these agents can actually run into each other, so kind of more added complexity there. Got a little video here, playing the game. See a little bit more how that works. So you kind of get the idea pretty quickly. The field can get pretty messy if you don't have much of a strategy going in. So you score points obviously by staying alive and hitting asteroids. You can modify. It's up to you during training if you want to modify how your agent is earning points, obviously, to encourage different behaviors during learning. And we will give you the final kind of scoring criteria and objective function for performance-wise. And it could include things like time your agent stays alive, asteroids destroyed, as well as firing accuracy. But obviously this is a list that can change. Information available to your controller within the environment would be vehicle position and velocity, asteroid positions and velocity, projectiles fired, etc. Kind of all this state information in the game will be available. And you are also able to create your own additional metrics or methods such as asteroid density maps, threat prioritization, path planning. That will be up to you to create additional information for your controller if you think it's needed. So we kind of talked about the seminars a little bit. We will give a seminar on genetic algorithms and using them to optimize fuzzy inference systems. And we'll include some other info on other gradient-free optimization algorithms and some resources for you guys there. But teams, you guys will not be restricted on how you want to, on your learning and optimization methods for your controller at all. So whatever you have experience in or whatever you think will be best for the situation, definitely feel free to use that. So as we said, the final version for the competition, the final version of your controller will need to be sent to us about 1 week before the competition, like we had that date. and we the organizers will need access to your repo. We will also have 10-minute presentations for the given by the teams with 5-minute question and A to present what you've done. You can include video showing your process. How are you describing your explainability and what kind of results were you able to achieve?
Hey, Lynn, if I can butt in real quick, that amount of time might be dependent on the number of teams that we get. So depending on what happens with the registration numbers this week, that can still change. But the teams will have an opportunity to show what they've done.
Yeah, always interesting to see those presentations. And we will have these new scenarios created that all the team agents, all the controllers will be playing. Like I said, single agent, multi-agent, number of asteroids, position, there's all kinds of scenarios that we'll come up with that will be new to you guys that you won't see before the competition. And then that resulting score will be factoring into your overall score. And of course, don't forget to create an awesome name for your fuzzy agent, always an important aspect. And awards, I bet everybody is excited about the awards. Um, Awards for first through third place will be given based on overall team score as determined by the scoring criteria. We don't have all the numbers set exactly, but first place team will receive $1,000 or around there or a little bit more. So some pretty big deal on the awards there. And we will also have some smaller awards, additional awards for not necessarily first through third place, but for the teams that we think had the most explainable solution, the most innovative solution, and the most computationally efficient solution are our categories for now there. I will just leave this screen up if you guys have any questions now, and you guys, if you want to note down our emails for asking questions in the future, or if you have any questions now, we are happy to answer them.
Hi, Lynn.
Hello.
It's Anirudh here. I had a question about is there a list of the last year's repos for the participants so that we can avoid having similar solutions?
Oh, that's an interesting question.
I mean, we do have last year's repository links. Whether they are still active or not, I'm not sure. And some of them were private and then made public, and they might be private again. As
Okay.
far as being too similar, I wouldn't worry about that. Unless you have already looked at their solutions. I mean,
I just saw the videos, so you can probably just avoid doing the same things that they explained. But yeah, I just wanted to know if there's a way, if that thing is available.
well, I mean, avoiding the repository should be fairly easy if you're not specifically searching for it.
Okay.
But if you have concerns about that, we can definitely discuss that when
Okay.
time comes. Yeah.
Okay.
Yeah, I mean, we do encourage everybody to come up with their own creative, original solutions, obviously.
Yeah. Okay. All right. Thanks.
Yeah, absolutely. Someone asked in the chat if we will have recordings for future meetings. Yes, we will. We will be recording all of these and probably uploading them all onto the YouTube channel. Regardless of whether we do that or not, we'll make sure that everybody who wants access to that recording can get it. Yeah, in fact, we will be uploading this recording to the YouTube channel relatively soon. That way, the folks that couldn't make the meeting today can review the kickoff slides. Barnabas said, "Thank you for the recordings." Yeah, absolutely. It also makes it easier for everybody by doing that. So we didn't have a dedicated stop time, but I'm happy to hang out and answer any other immediate questions. Also, of course, feel free to email the organizers with whatever questions you have. Lynn, actually, if you don't mind leaving that up. But also, absolutely join the Slack if you are competing, and the website has all this information as well. Just in case, let me go ahead and put the website link in the chat, just in case anybody missed it.
Can you also put the Slack link just in the chat? I joined late, so if you mentioned
Oh,
it,
yeah.
it is.
Yes. Here is the Slack as well. Oh, I might have sent that privately to somebody. Okay. Apparently, WebEx defaulted me to sending private messages, so sorry about that.
Okay, I got it now.
Nice. Do you want me to put the website link up, or do you got it?
I got it.
Okay.
I was having technical difficulties. Apologies.
Happens.
It does. Yeah, I highly encourage everybody to check out the videos for the live stream from last year and also the highlight video. Brandon made a really fun highlight video. Also, that way you don't have to sit through the multiple hours of live stream.
Yeah, but if you don't have any questions, I think we're pretty much officially done. So
Yeah.
don't need to stick around unless you have questions, and you can always email us if you think of anything, or message us in Slack once you get joined in the Slack.
Yeah, I will say that the Slack is one of the best places to be if you're going to be in the competition. There's a lot of back and forth between a lot of student teams as well that is not going to be captured in the email list that we'll send out major announcements by email as well, of course, but there's a lot of other info and a lot of interesting things in there too. All right. Well, if there aren't any other questions or comments or anything, I guess we'll call that a wrap. And yeah, again, feel free to contact us with any questions. Lynn, do you have anything else?
No, thanks to everybody who showed up to this.
Yeah. Thanks,
And
Barnabas. Yeah, us too.
we'll
I'm
see you
excited.
around.
This year is going to be really interesting. All right. Well, say that is the kickoff. Thanks, everybody.
Hi, everybody.